And um, so we looked on the y variable. We also looked on the x variable. We looked on the gradient, and we also looked on our y-intercept, which is c, right? So our equation of a line should be y equal mx plus c. All right. Let me plug in my charger before this thing dies. All right, so we now will go to calculating. All right, so for a y-intercept, you should be able to identify the y-intercept on the graph, but you won't be able to identify the gradient. You won't know, you won't have a value for the gradient. So that's what we need to learn how to calculate today. All right, so for activity, you're required to the same table that you filled out. You're going to take the values from that and you're going to go ahead and plot your graph. Now, you should get graph paper by tomorrow. This will be done in your class for tomorrow. So by the end of the class, you should be able to send your graph and your gradient. All right, send the graph and your gradient in Google Classroom. All right,
So must draw a graph in our books.
right, you'll use graph paper. All right, so try and get access to graph paper by tomorrow, and we'll do this in class tomorrow. So we allot time, 1 hour. It shouldn't take you 1 hour to do this, right? But you'd get 1 hour in your class time to draw the graph. You can do it from even now. It doesn't take a lot of time, right? All right, so what is the difference between this graph and this particular graph here? What is the difference between this graph and this graph? Let's look on where the graph starts, right? What's the difference between this graph and this graph?
Sir, the Y intersection.
Right, so we can look on where the graph starts, right? So this graph starts where?
Zero, sir.
Right, and then this graph would start at 40 and
40.
1.21, 1.20, right?
Yes, sir.
Yeah, so these two graphs are the same graphs, right? These two graphs are the same graphs. If you look on the readings, they are the same, but we cut this graph because, as you can realize, there's not a lot of activity going on here in this area, right? So we can cut this out. Agreed? All right. So if your results start at, right, let me go back. If your results start at 42, your graph can start at 40, right? You can start the graph at 40. All right. So if your length starts at it starts at 35, where can you start?
Repeat, sir.
All right. So for this graph, we see that it starts at 42. But if we drew the graph like how we were supposed to draw it, right? If we started from zero, we'd have a lot of unwanted space here, waste of graph paper. But we want to
Yes.
use up most of our graph paper. So what that means, we can cut our graph starting at 40 because our result starts at 42,
Yes, sir.
right? Our result starts at 42, so therefore we can start at 40. So let's say our result started at 33, right? Where could we start? We could start at 30, right?
35.
30.
Third,
Yeah, we could start at 30. So if our results start at 33, we could start at 30. If we start at 35, we could also start at 30. What we want to get at is that if we have a graph and most of the spaces, right, not used, we have a lot of unused space right here. right? Most of the space is not used. We can cut this and make it look something more like this, which we can get more information here, and we'll be able to plot our graph better and get our gradient. Are we understanding that?
Yes, sir.
All right, I need one more person. Are we understanding that? All right, okay. So the next step now is to go ahead and to calculate our gradient. Now, our gradient, wait, let me fix this for a brief moment. Let me just fix this for a second here. Um, working. Right, give me a second. All right, let's try it again. So, um, let me just repeat for the persons who are just coming in. Right. This graph, this particular graph here, and this graph is the same thing, right? You'll find that they're the same set of values. All right, the same set of values. This graph and this graph, but this graph starts at 0, and this graph starts at 40 and 1.21. But these graphs are the same, right? Now, why we start at 40 here, we essentially cut out most of this space right here to prevent wastage of our graph paper, right? Wastage, sorry, of our graph paper. We don't want to waste so much of our graph paper, so we cut out these areas here, right? We cut out these areas to prevent wasting our graph paper, right? So we can start at 40, and as a result, we can get more information here as it relates to join our graph, and our results are much more accurate. All right. Now we move on to the gradient. Now for the gradient, we said earlier that the gradient is a number that represents the steepness of our graph, right? So if our graph is much steeper, it will have a higher gradient. So for the gradient, we take 2 points on our graph. We take this point here, and we take this point, and we essentially find um we actually find a way to compare these 2 points using our gradient calculation. So we essentially find a way to compare these two. We have to try and compare them to see how steep our graph is. So we take this particular graph between the first 2 points and between the last 2 points, right? And we essentially find the value for these, right? So this is our formula for gradient: y2 minus y1 over x2 minus x1. So this will be our first reading. So this will be x1 and y1, right? X1 and y1, and this will be x2 and y2, right? X2 and y2. So we take two random points on the graph and we compare them. That's all we're doing for the gradient. That is all we're doing for the gradient. We take two random points. This is our first point and this is our second point. No, we just go like this: y2 and y1, right? And we have x2 and x1. Now, what is y2? in this case? Approximately 2.4, right? Yeah?
Yes, sir.
Yeah, so this is approximately 2.4. So y2 is 2.4, and what is y1?
1.5.
1.6, right? You see that? 1.6?
Okay, the Y1 that was look in between the 1.6 and the 1.4, sir.
Yeah, this seems to me like it's more on the line, right? It's more on the line. 1.6. Agreed? Are we all seeing that?
Yes, sir.
All right. I'm only here, Mr. Taylor. Is everyone else okay? Miss Hines, Mr. Hector, are we good?
Yes.
All right. Morgan, are we good? Morrison
Yes, sir.
and Morrison, are we good so far? All right. I hope Miss Morrison is paying attention. Right. Now we then have x2, right? X2. What is in the middle of 55 and 60? What is in the middle of 55 and 60? Right? So we have 55 here and we have 60 here. Right? In the middle would be, all right, what is in the middle of 0 and 5?
3. Oh.
All right, so we're close. Right? So between 0, divide 5 by 2. You have a calculator, divide 5 by 2.
Sir, me just no say answer.
4.1. 2.1, sorry.
2.1.
Mistake. Yes, sir. 2.
All right, let's try it again. So you have a calculator, put 5 divided by 2.
Sir,
Maybe a
2.5.
2.5. Oh
All
my
right,
God, I'm so good.
so 2.5. So in between 0 and 5, you would have 2.5, right? Now, in the middle of 55 and 60, how much would you have? You'd essentially add 55 to 2.5, right?
Yes, sir.
Yes,
So how much would
sir.
you get?
Sir, what did you say? 50 point how many?
55 and 60. So it would be
55 plus 60.
no 55 plus 2.5.
57.5.
Right. So in the middle of 55 and 60, you would have 57.5. Are we all seeing that?
Yes, sir.
All right. Now, what is in the middle of 40 and 45?
42.5.
Right. So 42.5
Oh
would be
my
here.
God.
Right. 42 point. Are we all seeing that? Hector, are we seeing that?
Yes, sir.
Right. 42.5. No. What is a little bit? Because we realize that this point is just a little bit above 42.5. What would this be approximately?
43.
Yeah. So that would be 43. So x1 would be approximately 43 and x2 would be 57.5. Are we all seeing that? Morgan, are we seeing that?
No, sir.
No, you're not seeing that. If you're not seeing it, please stop me. All right. I don't want to. I don't probably. I sometimes I forget to check up on everyone. Right. What are you not seeing? The 42.5?
What Mr. Many come off fight, so
All right, let's do it
I
again
was
then.
on the meeting.
All right, so you understand this? Between 0 and 5? Do you understand?
Yes,
Yeah, so in between 0 and 5, you'll have 2.5. No, in between 55 and 60, right? It's still the same thing. We would have 57.5, right? Is that the case?
Yes, sir.
Right, so we'd have 57.5 between here. No, for this particular one, it is not exactly on 42.5. It is a little bit above it, right? So in the middle of 40 and 45, what do we have? What do we have here? Between 40 and 45. Morgan, what do we have between 40 and 45?
between 40 and 45,
Yeah, what would be in the middle here, right?
43.
Yeah, approximately 43. But as you said, between 0 and 5, we have 2.5. So all we would do is add 2.5 here, right? 2.5, and then that
Mm-hmm.
would give us 42.5, right? So it's an approximation. It is not exactly 43, but we're just making an approximation. I just want to understand that x1 here would be 43, right? 43 would be here. So we plug in our values. Let us get back our let's get back our gradient equation. So we have m1, m, which is our gradient, right? Remember that this is gradient. M means gradient is equal to y2 minus y1 over x2 minus what?
X1.
Right, x1. So y2 minus y1 over x2 minus x1. What is our value for y2 again?
2.4.
Right, so we have
Um,
2.4 here minus 2.4 minus 1. What?
1.6.
1.6, right? 1.6. And what do we have down here? X2 is what?
57.5.
57.5. And what is X1?
42.5.
Right? Remember, X1 would be 43, right? It would be a
Yeah,
little bit above it.
43.
Yeah? Are we all seeing
Yes.
this now? If you're not seeing this, please let me know. We understand this? Are we understanding this here?
Yes, sir.
Yes, sir.
All right. So we can move on then. So at the top, we have 2.4 minus 1.6. What are you getting there? 2.4 minus 1.6. 2.4 minus 1.6. What is that in a calculator?
Sir, could you please repeat?
At the top, we have 2.4 minus 1.6. What are we getting for that? What is the answer?
2.4 minus 1.6.
Yeah.
Sir, 0.8.
0.8. Everyone gets 0.8.
Yes, sir. The answer is 0.8.
So 0.8 at the top, right? And what do we have down here? 57.5 minus 43. What do we get? 57.5 minus 43. Anybody get the answer to it?
Come in, sir. Come in. $14.5, sir.
All right, everyone get 14.5.
Yes, sir.
All right, so let's put 14.5 here. So what would you do in this situation? We have 0.8 over 14.5. How do we find our final answer?
Divide, sir.
All right, so we divide what by what?
14.5.
We divide 0.8 by,
0.8 by 14.5.
right? So 0.8 divided by 14.5. What's our final answer?
0.05.
All right, so we get 0.05 was our final answer. Are we all getting 0.05?
Yes, sir.
All right. Need one more confirmation.
Sir, 0.8 divided by
14.5.
14.5.
0.05.
All right, so final answer will be 0.05. No, are we all good now? We understand?
Yes, sir.
All right, so you'll be doing the same thing here in your activity. I know we're out of time now, right? I will post this on Google Classroom. All right, I will post this on Google Classroom. Let me see if I can bring up the activity now, right? Quickly. 1 second. You have a class now, right?
Yes, sir.
All right, let me just bring it up quickly, right? Give me 1 second. Grade 9 activity. I'm going to do this. Alright, so Travis is a little late. Yes, can get an activity. All right, so this is what you'll be getting. Now, this is your table. Remember, we filled this out the last class, right? Bear with me for a few more seconds, right? We filled this out the last class, right?
Speaking to the TVJ's College program, Mr.
Right?
Golfer said the situation is
Can you
complex.
hear me?
Yes, sir.
Yeah, we fill this out. Now you're required to plot a graph. So I'm going to need a graph tomorrow. What you'll be doing tomorrow, plotting a graph. On the y-axis, you will have p rad squared, right? P rad squared, and our x-axis will have what?
Length M.
Right. So length will be down here. All right. Length will be down here, and we have period squared up here. Is that clear?
Yes, sir.
All right. And then you're going to find your gradient. So after you plot a graph, you're going to take 2 points, something like this, and you would draw a triangle like this, and you will find the values of your points. Right. Remember, this is x2, y2. This is x1, y1. So you probably want to take a picture of this. All right. Take a picture of this quickly. So the gradient m equal y2 minus y1 over x2 minus x1. All right. Is that
So will
clear?
this be in Google Classroom?
Yes, sir.
All right. So this is the same thing in Google Classroom, but for this one, you're going to be actually plotting a graph now. So B and C have been added. B and C, and you're going to find the gradient. All right. All right. All the best,
Yes, sir.
everyone.
Same to you, sir.
All right.